In proof number 2, we're given that G is parallel to H and that angle 1 is congruent to angle 2. And we're going to need to use that information to prove that P, we want to show that P is parallel to R. So remember, to prove that two lines are parallel, we have to show one of those relationships. The alternate interior or exterior, consecutive interior or exterior, or corresponding. So hopefully if you look at P and R and we try to see what we're going to get to, we need to say that 3 and 2 are congruent. Because if we can say that 3 and 2 are congruent, those are the only two angles really dealing with line P and line R. If we can say those are congruent, we can conclude that those are parallel because they are corresponding angles with those two lines. So eventually we need to show that angle 2 is congruent to angle 3. So we know we're working towards that in every step of our proof. So we're given that G is parallel to H, and angle 1 is congruent to angle 2, and that is given. So we know 1's congruent to 2, and we know eventually we need to say that 2 is congruent to 3. So this works a lot like proof number 1 did. We know because G and H are parallel, 1 is congruent to 3. And that is because they are corresponding angles. If 1 is congruent to 2 and 1 is congruent to 3, then I know that 2 is congruent to 3. And that is by transitive. So we've successfully said that 2 and 3, that corresponding angles are congruent along line P and line R. So if that is true, we can conclude that P is parallel to R, and that is by corresponding angles. So your last statement there, or your last reason there, has to explain what allowed you to conclude that those lines are parallel, and it is because those corresponding angles are congruent.